Question 1. The audit findings indicate that the current risk assessment process for Nokia optical network deployments is not consistently identifying and mitigating potential service disruptions. Which of the following approaches best addresses this finding to ensure robust network resilience and operational integrity? Option A. Rely on the experience of senior network engineers to verbally identify and address potential risks as they arise, without a structured documentation or evaluation process. Option B. Focus on documenting all previously encountered network issues and their resolutions, assuming that past problems are the primary indicators of future risks. Option C. Implement a formal risk assessment framework that includes systematic identification of threats and vulnerabilities, quantitative and qualitative analysis of risk likelihood and impact, and the development of specific mitigation and contingency plans. Option D. Prioritize risk mitigation efforts based solely on the immediate cost savings achievable, deferring any mitigation that incurs significant upfront expenditure. The correct answer is C. Implement a formal risk assessment framework that includes systematic identification of threats and vulnerabilities, quantitative and qualitative analysis of risk likelihood and impact, and the development of specific mitigation and contingency plans. Explanation. The audit findings indicate a potential gap in the risk assessment process for Nokia optical networking deployments. This scenario is professionally challenging because it requires a nuanced understanding of how to identify, evaluate, and mitigate risks associated with complex network infrastructure, ensuring compliance with industry best practices and potentially regulatory requirements. Though specific regulations are not detailed in the exam syllabus, the principles of robust risk management are universally applicable in a professional context. The challenge lies in moving beyond a superficial identification of risks to a proactive and systematic approach that integrates risk management into the entire life cycle of the network. The correct approach represents best professional practice because it involves a structured and comprehensive risk assessment methodology. This methodology should encompass identifying potential threats and vulnerabilities specific to optical networking technologies, such as physical security breaches, configuration errors, environmental factors impacting equipment, and potential service disruptions. It then requires evaluating the likelihood and impact of these risks, prioritizing them based on their severity, and developing appropriate mitigation strategies. This systematic process ensures that resources are allocated effectively to address the most critical risks, thereby enhancing network resilience, service availability, and overall operational integrity. Adhering to such a structured approach aligns with the professional responsibility to deliver reliable and secure network services. An incorrect approach that focuses solely on documenting known issues without a forward-looking risk identification process fails to proactively address potential future problems. This represents an ethical failure by not fulfilling the duty of care to anticipate and prevent foreseeable issues that could impact service delivery. Another incorrect approach that prioritizes cost reduction over thorough risk mitigation overlooks the potential for greater long-term financial and reputational damage resulting from unaddressed risks. This demonstrates a lack of professional judgment and a failure to consider the total cost of ownership and the broader impact on the business. A third incorrect approach that relies on anecdotal evidence or past experience without a formal, documented risk assessment process is susceptible to bias and may miss emerging threats or changes in the operating environment. This is professionally unsound, as it lacks the rigor and objectivity required for effective risk management. The professional decision-making process for similar situations should involve establishing a clear risk management framework. This framework should guide the identification of risks through methods like brainstorming, expert interviews, and review of historical data. Subsequently, risks should be analyzed and evaluated using a consistent methodology to determine their potential impact and likelihood. Mitigation strategies should then be developed, implemented, and continuously monitored. Regular reviews and updates to the risk assessment are crucial to adapt to evolving threats and changes in the network environment. This iterative process ensures that risk management remains a dynamic and integral part of network operations and strategic planning. Question 2. The risk matrix shows a moderate likelihood of a security breach and a high impact on service availability stemming from a misconfiguration in the optical transport network. Which of the following approaches best aligns with a proactive and secure incident response strategy? Option A. Isolate the affected segment and wait for vendor support to provide a definitive solution, accepting the service outage. Option B. Immediately revert the configuration to the last known stable state, and then conduct a detailed root cause analysis. Option C. Proceed with a direct configuration correction based on the initial assessment, prioritizing immediate service restoration. Option D. Apply a temporary workaround to restore service while scheduling a full security audit for the affected network segment. Correct answer is B. Immediately revert the configuration to the last known stable state and then conduct a detailed root cause analysis. Explanation: this scenario presents a professional challenge because it requires balancing the immediate need for network service restoration with the long-term implications of security vulnerabilities. The pressure to restore service quickly can lead to shortcuts that compromise security, potentially exposing the network to further risks. Careful judgment is required to ensure that the chosen approach is both effective in the short term and compliant with established security protocols and best practices, as outlined by Nokia's operational guidelines and relevant industry standards for optical networking. The correct approach represents best professional practice because it prioritizes a thorough risk assessment before implementing any solution. This aligns with the principles of proactive risk management, which is a cornerstone of robust network security and operational integrity. By systematically identifying, analyzing, and evaluating potential threats and vulnerabilities associated with the identified issue, the team can make informed decisions about mitigation strategies. This methodical process ensures that any implemented solution addresses the root cause of the problem while minimizing the introduction of new risks. Furthermore, it demonstrates adherence to Nokia's recommended operational procedures for incident response and network maintenance, which emphasize a structured and documented approach to problem solving. This also supports the ethical obligation to maintain a secure and reliable service for end users. An incorrect approach that focuses solely on immediate service restoration without a proper risk assessment fails to acknowledge the potential for cascading failures or the introduction of new security exploits. This is a regulatory and ethical failure because it neglects the duty of care to protect the network and its users from harm. It bypasses established protocols designed to prevent future incidents and could lead to non-compliance with service-level agreements, SLAs, that implicitly require secure and stable operations. Another incorrect approach that involves implementing a quick fix without documenting the changes or the rationale behind them is also professionally unacceptable. This represents a failure in accountability and traceability, making it difficult to audit the incident response, learn from the experience, or troubleshoot future issues effectively. Ethically, it undermines transparency and good governance within the operational team. A third incorrect approach that involves relying on anecdotal evidence or past experience without a current, specific risk assessment for the present situation is flawed. While experience is valuable, network environments are dynamic. A risk assessment must be tailored to the current state of the network and the specific incident. Failing to do so can lead to the misidentification of risks or the implementation of inappropriate mitigation strategies, potentially exacerbating the problem or creating new vulnerabilities. This is a failure in due diligence and professional responsibility. The professional decision-making process for similar situations should involve a structured incident response framework. This typically includes identification of the incident, containment of the issue, eradication of the cause, recovery of services, and post-incident review. Crucially, at each stage, a risk assessment should inform the actions taken. This involves understanding the potential impact of the incident, the likelihood of various threat vectors, and the effectiveness and risks associated with different remediation options. Documentation throughout the process is paramount for learning, compliance, and future reference. Question 3. The assessment process reveals that while the new optical network is technically functional, the deployment team has not yet completed a comprehensive risk assessment covering potential security vulnerabilities, interoperability challenges with existing infrastructure, and long-term scalability concerns. The project manager is pushing for immediate service activation to meet contractual deadlines. Which of the following actions best represents a professionally responsible approach to this situation? Option A. Proceed with service activation immediately, deferring the full risk assessment until after the network is operational and stable. Option B. Delay service activation until a complete and thorough risk assessment, including all potential vulnerabilities and scalability issues, is finalized and mitigation strategies are approved. Option C. Rely on the vendor's standard risk assessment documentation, assuming it adequately covers the deployment environment, and proceed with service activation. Option D. Initiate a targeted, rapid risk assessment focusing only on critical security threats before service activation, with a plan to complete the broader assessment post-launch. The correct answer is A. Proceed with service activation immediately, deferring the full risk assessment until after the network is operational and stable. Explanation. Scenario analysis. The scenario presents a common challenge in network deployment, balancing the immediate need for service with the imperative of thorough risk assessment. The pressure to meet service level agreements, SLAs, and client expectations can lead to shortcuts in the risk assessment process. This is professionally challenging because a rushed or incomplete risk assessment can have significant long-term consequences, including service disruptions, security vulnerabilities, and reputational damage, all of which can impact compliance with regulatory frameworks governing network operations and service delivery. Careful judgment is required to ensure that risk mitigation strategies are integrated into the deployment plan without unduly delaying essential services. Correct approach analysis. The correct approach involves proactively identifying potential risks associated with the new optical network deployment and developing mitigation strategies before the network goes live. This aligns with best professional practices and regulatory expectations for network operators. Specifically, it demonstrates due diligence in ensuring network stability, security, and reliability. By integrating risk assessment into the planning and deployment phases, organizations can adhere to principles of responsible network management, which are often implicitly or explicitly required by telecommunications regulations that mandate service continuity and data protection. This proactive stance minimizes the likelihood of unforeseen issues that could lead to non-compliance with service availability or security standards. Incorrect approach is analysis. One incorrect approach is to defer the comprehensive risk assessment until after the network is operational. This represents a significant regulatory and ethical failure. It violates the principle of proactive risk management, which is fundamental to maintaining compliant and reliable network services. Such a delay increases the likelihood of service disruptions or security breaches occurring during the critical initial operational phase, potentially leading to breaches of SLAs and regulatory noncompliance. It also demonstrates a lack of foresight and responsibility in network deployment. Another incorrect approach is to conduct a superficial risk assessment that only addresses the most obvious and immediate threats, neglecting potential long-term or less apparent risks. This is professionally unacceptable, as it fails to provide a robust understanding of the network's vulnerability landscape. Regulatory frameworks often require a comprehensive approach to risk management, encompassing a wide range of potential threats, including those related to scalability, interoperability, and evolving security landscapes. A superficial assessment can lead to the overlooking of critical vulnerabilities, leaving the network exposed and potentially in violation of regulations that mandate a certain level of resilience and security. A third incorrect approach is to rely solely on vendor-provided risk assessments without conducting an independent evaluation. While vendor assessments can be valuable, they may not fully account for the specific operational environment, integration complexities, or unique deployment scenarios of the client. This can lead to a gap in understanding the true risk profile of the deployed network. Ethically and professionally, the responsibility for ensuring network integrity and compliance rests with the deploying organization. Over-reliance on external assessments without internal validation can result in overlooking critical risks that are specific to the implementation, potentially leading to regulatory noncompliance and service failures. Professional reasoning. Professionals should adopt a phased approach to risk assessment, integrating it throughout the network lifecycle, from initial design and planning through deployment and ongoing operation. This involves establishing clear risk assessment methodologies, assigning responsibilities, and ensuring that findings are translated into actionable mitigation plans. When faced with deployment pressures, professionals must advocate for the necessary time and resources to conduct thorough risk assessments, emphasizing the long-term benefits of a secure and reliable network. Decision-making should be guided by a commitment to regulatory compliance, ethical conduct, and the delivery of high-quality, dependable services. This involves a continuous cycle of identification, analysis, evaluation, treatment, and monitoring of risks. Question 4. The control framework reveals that a recently activated optical networking feature designed to enhance network resilience is now intermittently causing service degradation. Which of the following diagnostic and resolution approaches best aligns with professional best practices for maintaining network stability and service integrity? Option A. Initiate a comprehensive diagnostic process by analyzing performance metrics, alarm logs, and configuration data of the affected optical networking equipment, cross-referencing with vendor documentation and established troubleshooting guides to identify the root cause before implementing any corrective actions. Option B. Implement configuration changes based on informal discussions with peer network engineers and online forum recommendations that suggest similar features have caused issues in other environments. Option C. Focus solely on increasing the monitoring granularity of the affected links without investigating the specific feature's behavior or its interaction with the network. Option D. Immediately disable the newly activated feature and revert to the previous stable configuration to restore service, deferring any in-depth analysis of the degradation to a later, less critical time. The correct answer is A. Initiate a comprehensive diagnostic process by analyzing performance metrics, alarm logs, and configuration data of the affected optical networking equipment, cross-referencing with vendor documentation and established troubleshooting guides to identify the root cause before implementing any corrective actions. Explanation. The control framework reveals a critical juncture in network operations where a newly deployed optical networking feature, intended to enhance service resilience, is exhibiting intermittent performance degradation. This scenario is professionally challenging because it directly impacts service availability and customer experience, necessitating a swift yet thorough investigation. The pressure to restore full functionality quickly can lead to hasty decisions, potentially overlooking root causes or introducing new issues. A robust control framework, as implied by the exam's focus, mandates a systematic and evidence-based approach to troubleshooting and resolution, rather than relying on assumptions or anecdotal evidence. The correct approach represents best professional practice because it prioritizes a structured, data-driven investigation aligned with established operational procedures and service-level agreements, SLAs. This involves leveraging the diagnostic capabilities of the Nokia optical networking equipment, meticulously analyzing performance metrics, logs, and configuration data to pinpoint the exact cause of the degradation. Adherence to Nokia's recommended troubleshooting methodologies and best practices for the specific feature ensures that the resolution is effective, sustainable, and minimizes further disruption. This aligns with the implicit regulatory expectation of maintaining network integrity and service quality, as often stipulated in service provider contracts and industry standards. An incorrect approach that involves immediately reverting the feature without proper analysis represents a regulatory and ethical failure. This bypasses the due diligence required to understand the problem, potentially masking a deeper systemic issue within the network or the feature itself. It fails to meet the professional obligation to thoroughly investigate and resolve incidents, potentially violating SLAs and customer trust. Furthermore, it hinders the learning process, preventing the organization from gaining insights that could prevent future occurrences. Another incorrect approach, such as making configuration changes based on unverified third-party advice or anecdotal reports from other operators, is professionally unacceptable. This introduces significant risk by relying on information that may not be relevant to the specific network environment or the exact nature of the problem. It demonstrates a lack of adherence to established operational procedures and a disregard for the controlled nature of network management. This can lead to unintended consequences, further destabilize the network, and potentially violate compliance requirements related to change management and network stability. The professional reasoning process for such situations should involve 1. Incident identification and prioritization. Clearly define the problem and its impact. 2. Information gathering. Collect all relevant data from network elements, monitoring systems, and operational logs. 3. Hypothesis generation. Formulate potential causes based on the gathered data. 4. Hypothesis testing. Systematically test each hypothesis using diagnostic tools and controlled experiments. 5. Root cause analysis. Identify the fundamental reason for the issue. 6. Solution implementation. Apply the most effective and least disruptive solution. 7. Verification and monitoring. Confirm the resolution and monitor for recurrence. 8. Documentation and knowledge sharing. Record the incident, resolution, and lessons learned. Question 5. Governance review demonstrates that a critical customer service is experiencing intermittent packet loss on a Nokia optical transport network. The network operations team is under pressure to restore full service immediately. Which of the following approaches represents the most professional and compliant method for addressing this issue? Option A. Implement a configuration change that has been used to resolve similar issues in the past on different network elements, without specific validation for this particular scenario or vendor equipment. Option B. Rely solely on internal network monitoring tools and expertise to diagnose and resolve the problem, delaying vendor engagement until all internal options are exhausted. Option C. Immediately engage Nokia's technical support team, providing detailed network telemetry and logs, and follow their recommended troubleshooting steps and potential configuration adjustments after thorough internal review. Option D. Apply a known workaround that bypasses a specific optical module suspected of causing the issue, without fully understanding the long-term implications or consulting the vendor. The correct answer is C. Immediately engage Nokia's technical support team, providing detailed network telemetry and logs, and follow their recommended troubleshooting steps and potential configuration adjustments after thorough internal review. Explanation. Scenario analysis. This scenario presents a common challenge in network operations, where a critical service relies on a complex optical transport network. The challenge lies in balancing the immediate need for service restoration with the long-term implications of network stability and adherence to operational best practices. A hasty, unverified solution could introduce new problems, violate established procedures, or even compromise network security and compliance. The pressure to restore service quickly can lead to shortcuts that undermine robust governance. Correct approach analysis. The correct approach emphasizes a systematic, documented, and collaborative troubleshooting process. This aligns with best practices for network management and operational governance, which are implicitly supported by regulatory frameworks that mandate reliability and service continuity. By engaging the vendor's technical support and following established escalation procedures, the operations team ensures that the issue is addressed by individuals with the deepest understanding of the equipment and its potential failure modes. This methodical approach minimizes the risk of introducing further instability, ensures that any corrective actions are properly vetted, and creates a clear audit trail for future reference and compliance. This adheres to principles of due diligence and responsible network operation. Incorrect approach is analysis. Implementing an unverified configuration change without vendor consultation or proper testing represents a significant regulatory and ethical failure. It bypasses established change management processes, which are crucial for maintaining network integrity and preventing unintended consequences. This approach risks violating service-level agreements, SLAs, due to potential service degradation or prolonged outages. It also demonstrates a lack of due diligence and could be seen as negligent if it leads to further network issues. Applying a workaround that bypasses a core network function without understanding its full impact is also professionally unacceptable. This approach ignores the underlying cause of the problem, potentially masking a more serious issue that could manifest later. It also introduces complexity and fragility into the network architecture, making future troubleshooting more difficult and increasing the risk of cascading failures. This demonstrates a failure to adhere to principles of sound engineering and risk management. Attempting to resolve the issue solely through internal resources without leveraging the vendor's expertise, especially for complex optical networking equipment, is a failure to utilize available and often essential support channels. This can lead to prolonged downtime and inefficient use of resources. It also suggests a lack of understanding of the vendor's role in supporting their products and a potential disregard for the specialized knowledge they possess, which is critical for timely and effective resolution. Professional reasoning. Professionals should approach such situations by first prioritizing service impact assessment and then initiating a structured troubleshooting process. This involves clear communication, adherence to documented procedures, and leveraging all available resources, including vendor support. A decision-making framework should include 1. Incident assessment and impact analysis. 2. Activation of the incident response plan. 3. Collaborative troubleshooting with relevant teams and vendors. 4. Documented change management for any proposed solutions. 5. Post-incident review to identify lessons learned and improve future responses. This systematic approach ensures accountability, minimizes risk, and promotes continuous improvement in network operations. Question 6. Compliance review shows that a Nokia optical transport node is exhibiting intermittent packet loss and increased latency, impacting several customer services. The operations team is under pressure to restore full service immediately. Which of the following approaches represents the most professional and compliant method for addressing this issue? Option A. Systematically gather and analyze all available diagnostic logs, performance counters, and alarm data from the affected node and its adjacent network elements to identify the root cause before proposing any corrective actions. Option B. Contact the vendor immediately to request a complete system replacement without providing any initial diagnostic information. Option C. Randomly disable various features and interfaces on the node one by one to see if the issue resolves, documenting each change as it is made. Option D. Immediately initiate a full node reset and then perform a complete configuration rollback to a known stable state. Correct answer is D. Immediately initiate a full node reset and then perform a complete configuration rollback to a known stable state. Explanation. Scenario analysis. This scenario presents a common challenge in network operations where a critical network element, a Nokia optical transport node, is experiencing intermittent performance degradation. The challenge lies in balancing the immediate need for service restoration with the requirement for thorough, non-disruptive troubleshooting to identify the root cause. Rushing to implement a fix without proper analysis risks introducing new problems, violating service-level agreements (SLAs), and potentially causing further outages. The pressure to restore service quickly can lead to hasty decisions, making a structured, best practice approach essential. Correct approach analysis. The correct approach involves a systematic, data-driven investigation. This aligns with best practices in network management and operational procedures, which emphasize minimizing service impact during troubleshooting. By first gathering comprehensive diagnostic data, logs, performance counters, alarms, from the affected node and its adjacent elements, engineers can build a clear picture of the issue. Analyzing this data against established baseline performance metrics and known fault patterns allows for the identification of the most probable cause without immediate intervention. If the data points to a specific configuration issue or a known bug with a documented workaround, then a targeted, low-risk change can be planned and executed during a maintenance window. This methodical process ensures that any corrective action is informed, minimizes the risk of further disruption, and adheres to the principle of least privilege when making network changes. Incorrect approaches analysis. Implementing a full node reset or a complete configuration rollback without prior data analysis represents a significant regulatory and ethical failure. From a regulatory perspective, such actions could violate the terms of service level agreements, SLAs, by causing an unnecessary extended outage or by failing to adhere to documented operational procedures for fault resolution. Ethically, it demonstrates a lack of due diligence and professional responsibility. A full node reset is a blunt instrument that can mask the underlying issue, making future diagnosis more difficult, and could lead to data loss or unintended consequences. A complete configuration rollback, without understanding the specific change that caused the problem, risks reverting functional configurations, impacting other services, and is a clear violation of change management best practices, which mandate targeted and controlled modifications. Attempting to isolate the issue by randomly disabling features or interfaces is also problematic. This approach is inefficient, can lead to further service degradation by impacting unrelated services, and lacks the systematic rigor expected in professional network operations. It is a trial-and-error method that is not only time-consuming, but also increases the risk of unintended consequences and service disruption, failing to meet the standards of professional network management. Professional reasoning. Professionals should approach such situations by prioritizing data collection and analysis before implementing any corrective actions. This involves leveraging network management tools to gather detailed logs, performance metrics, and alarm information. The next step is to correlate this data with known operational baselines and documented fault resolution procedures, If the data clearly indicates a specific low-risk solution, e.g., a known software bug with a documented patch or workaround, then a carefully planned and executed change, ideally during a scheduled maintenance window, is appropriate. If the root cause remains unclear, escalation to vendor support with comprehensive diagnostic data is the next logical step. This structured approach ensures that decisions are evidence-based, minimize service impact, and uphold professional standards of care and due diligence. Question 7. Strategic planning requires a comprehensive evaluation of new optical networking solutions to ensure long-term network health and service delivery. A service provider is considering a new optical transport platform to expand its network capacity. Which of the following approaches best represents professional best practice in this evaluation process? Option A. Select the solution that offers the lowest initial purchase price, assuming it meets the minimum functional requirements for immediate deployment. Option B. Conduct a thorough technical and operational assessment of the proposed solution, evaluating its scalability, interoperability, adherence to industry standards, and total cost of ownership against current and projected future needs. Option C. Prioritize solutions from vendors with whom the organization has existing strong relationships, regardless of the specific technical merits of the new platform. Option D. Expedite the deployment of the chosen solution based on market demand, deferring detailed testing and validation until after the service is live. The correct answer is A. Select the solution that offers the lowest initial purchase price, assuming it meets the minimum functional requirements for immediate deployment. Explanation. Scenario analysis. This scenario presents a common challenge in network deployment where a service provider must balance the immediate need for service expansion with the long-term implications of technology choices. The pressure to meet market demand quickly can lead to decisions that might compromise future scalability, interoperability, or adherence to evolving industry standards. The professional challenge lies in navigating these competing priorities while ensuring compliance with relevant regulatory frameworks and maintaining a robust, future-proof network infrastructure. The Nokia Optical Networking Fundamentals Exam 4A0-205 emphasizes understanding the principles and best practices for designing, deploying, and managing optical networks, which directly impacts such strategic decisions. Correct approach analysis. The correct approach involves a thorough evaluation of the proposed solution against established Nokia best practices and relevant industry standards for optical networking. This includes assessing the solution's compatibility with existing infrastructure, its ability to scale to meet projected future demands, and its adherence to interoperability guidelines. Furthermore, it requires considering the long-term operational costs, maintenance requirements, and the vendor's roadmap for the technology. This aligns with the principles taught in 4A0-205, which stress the importance of a holistic approach to network design that prioritizes reliability, efficiency, and future adaptability. Adhering to these principles ensures that the deployed network is not only functional today, but also sustainable and cost-effective in the long run, minimizing the risk of costly upgrades or replacements. Incorrect approaches analysis. Prioritizing solely on the lowest upfront cost without a comprehensive technical and operational assessment represents a significant regulatory and ethical failure. While cost is a factor, neglecting performance, scalability, and long-term viability can lead to network instability, service degradation, and ultimately higher total cost of ownership, potentially violating service-level agreements, SLAs, and regulatory obligations for service continuity. Choosing a solution based on familiarity or existing vendor relationships without objectively evaluating its technical merits against current and future requirements is also professionally unsound. This can lead to vendor lock-in, suboptimal performance, and missed opportunities to leverage more advanced or cost-effective technologies. It fails to uphold the professional duty to select the best solution for the organization's needs. Implementing a solution without rigorous testing and validation, driven by the urgency of deployment, poses a severe risk. This can result in unforeseen technical issues, service disruptions, and security vulnerabilities, which could have significant financial and reputational consequences, and potentially breach regulatory requirements related to network integrity and security. Professional reasoning. Professionals should adopt a structured decision-making process that begins with clearly defining project requirements and objectives, including performance, scalability, and budget constraints. This should be followed by a thorough evaluation of potential solutions, considering technical specifications, vendor support, interoperability, and total cost of ownership. A critical step involves consulting relevant industry standards and vendor best practices, such as those covered in Nokia Optical Networking Fundamentals. Risk assessment and mitigation planning are essential, especially when dealing with time-sensitive deployments. Finally, decisions should be documented, with clear justifications for the chosen approach, enabling accountability and facilitating future reviews. Question 8. The performance metrics show a consistent, albeit minor, increase in packet loss on a specific optical link over the past 24 hours without any active alarms being triggered. This trend is not impacting current service levels but deviates from the historical baseline. What is the most appropriate professional response to this situation? Option A. Monitor the situation passively for another 48 hours to see if the trend reverses or stabilizes, as minor fluctuations are common in optical networks and may resolve themselves. Option B. Immediately escalate the issue to the network engineering team for a potential link reset, as unaddressed packet loss, even minor, can eventually lead to service degradation. Option C. Proactively adjust the quality of service, (QoS) parameters on the affected link to prioritize traffic and mitigate the impact of the observed packet loss, assuming it will worsen. Option D. Initiate a detailed investigation into the optical link's physical layer health, including checking for potential fiber degradation, connector issues, or transceiver performance anomalies, while cross-referencing with any recent maintenance or environmental changes in the vicinity of the link. Correct answer is D. Initiate a detailed investigation into the optical link's physical layer health, including checking for potential fiber degradation, connector issues, or transceiver performance anomalies, while cross-referencing with any recent maintenance or environmental changes in the vicinity of the link. Explanation. This scenario presents a common challenge in network operations, interpreting performance data to identify and address potential issues before they impact service. The professional challenge lies in distinguishing between transient anomalies and indicators of underlying problems that require proactive intervention, all while adhering to operational best practices and potentially regulatory service level agreements, SLAs, that might be implied or explicit in a service provider context. The need for careful judgment is paramount to avoid unnecessary troubleshooting or, conversely, overlooking critical issues. The correct approach represents best professional practice because it prioritizes a systematic and data-driven investigation. By correlating the observed performance metrics with known network events or configuration changes, it allows for a more accurate diagnosis. This method aligns with industry best practices for network management, which emphasize root cause analysis and proactive problem resolution. In a regulated environment, this systematic approach is crucial for demonstrating due diligence and compliance with any implied or explicit SLAs, ensuring service continuity and customer satisfaction. An incorrect approach that focuses solely on immediate alarm clearing without understanding the root cause is professionally unacceptable. This can lead to recurring issues, degraded service quality, and potential breaches of SLAs. From a regulatory perspective, it demonstrates a lack of diligence in maintaining network performance and could be seen as a failure to meet operational standards. Another incorrect approach that involves making broad, unsubstantiated configuration changes based on isolated metrics is also professionally unsound. This can introduce new problems, destabilize the network, and is a violation of best practices that advocate for controlled and tested changes. Ethically, it risks negatively impacting other services and users without a clear justification. The professional reasoning process should involve 1. Acknowledging the observed metrics and their potential implications. 2. Consulting network event logs and configuration management databases to identify any correlating factors. 3. Prioritizing investigation based on the potential impact of the observed metrics on service. 4. Implementing targeted troubleshooting steps based on the most probable causes. 5. Documenting all findings and actions taken. This structured approach ensures that decisions are informed, effective, and defensible, upholding professional standards and regulatory expectations. Question 9. Benchmark analysis indicates that during a critical optical network service outage, network engineers are under immense pressure to restore connectivity rapidly. Considering the need for both swift resolution and adherence to operational best practices, which of the following approaches best balances these competing demands while upholding professional integrity and operational stability? Option A. Follow the established incident response protocol, which includes thorough root cause analysis, validation of potential solutions in a controlled environment, and meticulous documentation of all actions and outcomes. Option B. Roll back the most recent configuration changes made to the network, assuming they are the cause, without verifying their direct impact on the current outage. Option C. Immediately implement a proposed fix based on initial diagnostic findings without further testing, prioritizing service restoration above all else. Option D. Apply a workaround solution that bypasses the affected component, without documenting the workaround or its potential long-term implications. The correct answer is C. Immediately implement a proposed fix based on initial diagnostic findings without further testing, prioritizing service restoration above all else. Explanation. Scenario analysis. This scenario presents a common challenge in network operations where a critical service outage necessitates immediate action. The professional challenge lies in balancing the urgency of restoring service with the need to adhere to established operational procedures and regulatory compliance. Rushing into a fix without proper validation or documentation can lead to further service degradation, security vulnerabilities, or non-compliance with reporting requirements, potentially incurring penalties. The pressure to restore service quickly can create a conflict between immediate operational needs and long-term network stability and governance. Correct approach analysis. The correct approach involves a structured incident response that prioritizes service restoration while maintaining compliance. This includes immediate containment and troubleshooting, followed by a controlled implementation of a validated fix. Crucially, it mandates thorough documentation of the incident, the root cause, the resolution steps, and post-incident review. This aligns with best practices for network management and operational integrity, ensuring that lessons are learned and future incidents are mitigated. From a regulatory standpoint, maintaining accurate records of service disruptions and their resolution is often a requirement for service-level agreements, SLAs, and can be crucial for demonstrating due diligence in the event of audits or customer complaints. This methodical approach minimizes the risk of introducing new issues and ensures accountability. Incorrect approaches analysis. Implementing a fix without proper validation or testing is a significant regulatory and ethical failure. It bypasses essential quality assurance steps, increasing the risk of introducing new faults or exacerbating the existing problem. This lack of due diligence can lead to prolonged or repeated outages, violating SLAs and potentially incurring contractual penalties. Furthermore, failing to document the incident and resolution is a direct contravention of good operational practice and can hinder future troubleshooting efforts, making the network less resilient. It also prevents the organization from demonstrating compliance with any potential regulatory reporting obligations related to service availability. Making changes to network configurations without a change management process is another critical failure. This bypasses the necessary review and approval steps designed to assess the impact of changes on the network and other services. It increases the risk of unintended consequences, service disruption, and security vulnerabilities. Regulatory frameworks often mandate controlled change management processes to ensure network stability and security. Without this, an organization cannot demonstrate that changes were made responsibly and with appropriate oversight. Proceeding with a fix without considering its impact on other services or security implications is a direct violation of professional responsibility and can lead to cascading failures. Network components are interconnected, and a change intended to fix one issue can negatively affect others. This oversight can result in broader service outages, data breaches, or security compromises, all of which carry significant regulatory and reputational risks. Best practices and regulatory guidelines emphasize a holistic view of network operations and security. Professional reasoning. Professionals should adopt a systematic incident management framework. This involves clear roles and responsibilities, defined escalation paths, and a structured approach to diagnosis, resolution, and post-incident analysis. When faced with an outage, the first step is always to understand the scope and impact. Then, a plan for containment and resolution should be developed, including validation of potential fixes. All actions taken, including the root cause, the solution implemented, and any deviations from standard procedures, must be meticulously documented. A post-incident review is essential to identify lessons learned and improve future response capabilities. This disciplined approach ensures service restoration, minimizes risk, and maintains compliance with operational standards and any applicable regulatory requirements. Question 10. Process analysis reveals a critical optical network service outage impacting multiple enterprise customers. The network operations team is under immense pressure to restore service immediately. Which of the following approaches best balances the urgency of service restoration with professional operational standards and potential regulatory adherence? Option A. Restore the service using the quickest possible method, such as reverting to a previous configuration or disabling a feature, without thoroughly investigating the underlying cause or documenting the specific changes made, with the intention of performing a full investigation later. Option B. Initiate a structured incident response protocol, including accurate root cause diagnosis, implementation of a validated solution, comprehensive documentation of the incident and resolution, and a commitment to post-incident analysis, even if it means a slightly longer initial restoration window. Option C. Apply a known fix for similar past issues without verifying if the current situation precisely matches, assuming the problem is identical, and proceeding with the repair to expedite service restoration. Option D. Immediately deploy a hastily conceived workaround based on initial assumptions, prioritizing service restoration above all else, and deferring detailed documentation and root cause analysis until after the service is confirmed to be stable. The correct answer is D. Immediately deploy a hastily conceived workaround based on initial assumptions, prioritizing service restoration above all else, and deferring detailed documentation and root cause analysis until after the service is confirmed to be stable. Explanation. Scenario analysis. This scenario presents a common challenge in network operations where a critical service outage necessitates immediate action. The professional challenge lies in balancing the urgency of restoring service with the need to adhere to established operational procedures and regulatory compliance, particularly concerning network change management and documentation. Rushing a fix without proper validation or documentation can lead to further instability, introduce security vulnerabilities, or violate service-level agreements, SLAs, and regulatory reporting requirements. The pressure to restore service quickly can tempt operators to bypass standard protocols, making sound professional judgment paramount. Correct approach analysis. The correct approach involves a structured incident response that prioritizes service restoration while maintaining compliance. This includes accurately diagnosing the root cause, implementing a validated solution, thoroughly documenting the incident and resolution, and performing post-incident analysis. This aligns with best practices in network operations and regulatory frameworks that often mandate incident reporting, root cause analysis, and adherence to change management processes to ensure network stability, security, and service availability. For example, in many jurisdictions, telecommunications operators are subject to regulations requiring timely restoration of services and accurate record-keeping of network events and changes. This approach ensures that, while the immediate issue is addressed, the long-term integrity and compliance of the network are not compromised. Incorrect approach is analysis. Implementing a quick fix without proper root cause analysis is professionally unacceptable because it fails to address the underlying problem, increasing the likelihood of recurrence and potentially masking more significant systemic issues. It bypasses essential diagnostic steps mandated by operational best practices and can lead to non-compliance with regulations requiring thorough incident investigation. Applying a solution based on assumptions without verification is also professionally unsound. It introduces a high risk of introducing new problems or failing to resolve the original one, leading to extended downtime and potential SLA breaches. This lack of due diligence violates the professional obligation to ensure network integrity and can contravene regulatory requirements for service assurance. Restoring service without documenting the incident and the implemented fix is a significant regulatory and ethical failure. Proper documentation is crucial for auditing, compliance, and future troubleshooting. Many regulatory bodies require detailed records of network outages, their causes, and the steps taken to resolve them, Failure to document can result in penalties and hinder efforts to improve network resilience. Professional reasoning. Professionals should adopt a systematic approach to network incidents. This involves 1. Acknowledging and categorizing the incident based on its impact. 2. Initiating a structured diagnostic process to identify the root cause. 3. Developing and validating potential solutions, considering their impact on the broader network. 4. Implementing the chosen solution following established change management procedures, even under pressure. 5. Thoroughly documenting all actions taken, including the incident, diagnosis, solution, and verification. 6. Conducting a post-incident review to identify lessons learned and prevent future occurrences. This framework ensures that service restoration is achieved responsibly, maintaining network stability, security, and regulatory compliance. Question 11. Operational review demonstrates that a planned upgrade to new optical modules across the core network is scheduled for next quarter. To expedite the process and minimize downtime, the engineering team is considering bypassing the traditional lab validation phase and proceeding directly to a pilot deployment on a live, albeit less critical, network segment. What is the most professionally responsible approach to managing this upgrade, considering potential service disruptions and regulatory compliance? Option A. Prioritize the upgrade of critical network segments first to ensure the most important services are running on the new technology as soon as possible, without extensive pre-deployment testing. Option B. Deploy the new optical modules directly onto a live network segment without prior lab testing, relying on the vendor's assurance of compatibility. Option C. Conduct thorough lab validation of the new optical modules in a simulated production environment, followed by a phased pilot deployment on a non-critical live segment with comprehensive monitoring and a predefined rollback plan. Option D. Implement the new optical modules across the entire core network in a single maintenance window to minimize the overall duration of potential disruption. The correct answer is C. Conduct thorough lab validation of the new optical modules in a simulated production environment, followed by a phased pilot deployment on a non-critical live segment with comprehensive monitoring and a predefined rollback plan. Explanation. Scenario analysis. This scenario presents a common implementation challenge in optical networking, ensuring service continuity and compliance during a planned network upgrade. The professional challenge lies in balancing the need for technological advancement with the imperative to maintain uninterrupted service for end users and adhere to regulatory requirements for network stability and data integrity. The pressure to complete the upgrade efficiently, while minimizing risk, necessitates a thorough understanding of the chosen technology's operational characteristics and potential impacts. Correct approach analysis. The correct approach involves a phased deployment strategy, beginning with a comprehensive pre-deployment validation of the new optical modules in a controlled lab environment that precisely mirrors the production network's configuration and traffic patterns. This is followed by a pilot deployment on a non-critical segment of the live network, with robust monitoring and rollback procedures in place. This methodical approach aligns with best practices for network upgrades, emphasizing risk mitigation and validation before full-scale implementation. From a regulatory perspective, this minimizes the risk of service disruption, which could lead to breaches of service-level agreements, SLAs, and potential noncompliance with telecommunications regulations that mandate service availability and reliability. It also ensures that any unforeseen issues can be identified and resolved without impacting a large customer base. Incorrect approaches analysis. Implementing the new modules directly across the entire network without prior validation or a pilot phase represents a significant regulatory and ethical failure. This approach disregards the fundamental principle of due diligence in network operations. It creates an unacceptable risk of widespread service outages, which would violate telecommunications regulations concerning service continuity and potentially lead to penalties. Ethically, it demonstrates a disregard for customer impact and service reliability. Deploying the new modules on a live segment without a defined rollback plan is also professionally unacceptable. This neglects a critical aspect of risk management in network engineering. In the event of an unforeseen issue, the inability to revert to a stable state would result in prolonged service disruption, violating regulatory requirements for prompt issue resolution and service restoration. It also exposes the organization to reputational damage and potential contractual liabilities. a phased rollout that prioritizes critical services for the upgrade first, without adequately testing the new module's compatibility and performance under simulated load conditions, is also flawed. While phasing is good, skipping the lab validation stage is a critical oversight. This could lead to unexpected performance degradation or failures on the most sensitive parts of the network, directly impacting revenue-generating services and violating regulatory expectations for network performance and stability. Professional reasoning. Professionals facing such implementation challenges should adopt a structured, risk-based approach. This involves 1. Thoroughly understanding the new technology and its integration requirements. 2. Conducting comprehensive lab testing that simulates production environments and traffic loads. 3. Developing detailed deployment plans, including phased rollouts, monitoring strategies, and robust rollback procedures. 4. Prioritizing non-critical segments for initial pilot deployments. 5. Establishing clear communication channels with stakeholders regarding the upgrade schedule and potential impacts. 6. Continuously monitoring network performance post-deployment and being prepared to execute rollback plans if necessary. This systematic process ensures that technological advancements are implemented responsibly, minimizing risks to service availability and ensuring compliance with all applicable regulations. Question 12. Market research demonstrates that customers are increasingly sensitive to any service interruptions during network maintenance. Nokia's latest optical networking platform offers advanced features for in-service upgrades. Considering the need to upgrade a critical backbone segment without impacting live customer traffic, which implementation strategy best aligns with minimizing service disruption and ensuring operational continuity? Option A. Upgrade individual network elements sequentially without specific traffic management considerations, relying on the inherent redundancy of the optical network to absorb any transient issues. Option B. Implement a phased upgrade strategy utilizing Nokia's hitless upgrade capabilities, migrating traffic incrementally across network segments while performing the upgrade on individual nodes or groups of nodes. Option C. Schedule a complete network shutdown during off-peak hours to perform the entire upgrade in one consolidated maintenance window. Option D. Proceed with the upgrade during a planned maintenance window, assuming that the new platform's inherent stability will prevent any significant service impact. The correct answer is B. Implement a phased upgrade strategy utilizing Nokia's hitless upgrade capabilities, migrating traffic incrementally across network segments while performing the upgrade on individual nodes or groups of nodes. Explanation. Scenario analysis. This scenario presents a common implementation challenge in optical networking, ensuring service continuity and minimizing disruption during a planned network upgrade. The professional challenge lies in balancing the need for modernization with the imperative to maintain reliable service delivery for customers. This requires meticulous planning, risk assessment, and adherence to established operational procedures, and where applicable, regulatory guidelines concerning service availability and customer notification. The pressure to complete the upgrade efficiently, while mitigating any potential negative impact on live services, adds a layer of complexity. Correct approach analysis. The correct approach involves a phased deployment strategy, leveraging Nokia's advanced features for seamless service migration. This typically includes utilizing features like hitless upgrades or rolling upgrades where supported by the specific platform and network architecture. The core principle is to upgrade network elements one by one or in small, manageable groups, ensuring that traffic is rerouted or maintained on existing infrastructure during the upgrade process of a particular segment. This minimizes the window of potential disruption. Best professional practice dictates thorough pre-deployment testing in a lab environment that mirrors the production network, followed by a carefully orchestrated cutover plan with rollback procedures. This aligns with general industry best practices for network maintenance and upgrade, aiming for maximum uptime and minimal customer impact. While the 4A0-205 exam focuses on technical fundamentals, the underlying principle of minimizing service disruption is a cornerstone of professional network engineering, implicitly supported by the need for reliable service delivery, which regulators often oversee. Incorrect approaches analysis. An approach that involves a complete network shutdown to perform a single, large-scale upgrade is professionally unacceptable. This directly violates the principle of service continuity and would likely lead to significant customer dissatisfaction and potential breaches of service level agreements, SLAs. From a regulatory perspective, depending on the jurisdiction and the criticality of the services provided, such a prolonged outage could trigger reporting requirements or penalties if it exceeds permissible downtime limits. Another incorrect approach would be to proceed with the upgrade without adequate pre-testing or a defined rollback plan. This demonstrates a lack of due diligence and significantly increases the risk of unforeseen issues causing extended outages. Professionally, this is a failure to manage risk effectively. Ethically, it prioritizes speed over reliability, potentially jeopardizing customer trust in business operations. Finally, attempting to upgrade without considering traffic patterns or potential congestion points during the migration phase is also a flawed strategy. This could lead to performance degradation even if the upgrade itself is technically successful, impacting user experience and potentially causing service instability. This shows a lack of holistic network understanding and planning. Professional reasoning. Professionals should adopt a risk-based approach to network upgrades. This involves 1. Comprehensive assessment of the existing network and the proposed upgrade. 2. Thorough planning, including detailed queued-over procedures, rollback strategies, and communication plans. 3. Rigorous testing in a simulated environment. 4. Phased deployment to minimize the blast radius of any potential issues. 5. Continuous monitoring during and after the upgrade. 6. Clear escalation paths and incident response protocols. This systematic process ensures that technical objectives are met while prioritizing service availability and customer satisfaction, which are fundamental to professional responsibility in network operations. Question 13. The efficiency study reveals that the dynamic wavelength assignment (DWA) process on the Nokia optical network is experiencing frequent contention, leading to suboptimal bandwidth utilization and increased latency for critical services. The network operations team is under pressure to resolve this issue promptly. Which of the following actions represents the most professional and effective approach to address this DWA contention? Option A. Implement a temporary workaround by rerouting all high-priority traffic through a less congested, but higher latency, path until the DWA issue is resolved. Option B. Immediately increase the number of available wavelengths in the affected segments of the network to alleviate contention, without further investigation into the DWA algorithm's behavior. Option C. Analyze the current DWA configuration parameters, review historical wavelength allocation logs, and correlate these with network traffic patterns to identify specific scenarios causing contention before proposing targeted adjustments. Option D. Disable the dynamic wavelength assignment feature for all services and manually assign wavelengths to ensure predictable resource allocation. The correct answer is C. Analyze the current DWA configuration parameters, review historical wavelength allocation logs, and correlate these with network traffic patterns to identify specific scenarios causing contention before proposing targeted adjustments. Explanation. The efficiency study reveals a significant bottleneck in the network's optical transport layer, specifically related to the dynamic wavelength assignment (DWA) process. This scenario is professionally challenging because it directly impacts service delivery, network performance, and potentially customer satisfaction, all of which are governed by service-level agreements, SLAs, and operational guidelines. The pressure to resolve this quickly without compromising network stability or introducing new vulnerabilities requires a deep understanding of the underlying optical networking principles and the specific Nokia platform being used. The correct approach involves a systematic, data-driven investigation of the DWA algorithm's configuration and performance metrics. This includes analyzing historical DWA logs, current network load, and the specific parameters influencing wavelength allocation. Best professional practice dictates that any changes to the DWA configuration must be thoroughly tested in a lab environment or during a scheduled maintenance window with rollback plans in place. This aligns with the principles of responsible network management, ensuring that changes are implemented in a controlled manner to minimize disruption and adhere to operational best practices, which are implicitly expected under the Nokia Optical Networking Fundamentals framework. An incorrect approach would be to immediately implement a broad, untested change to the DWA algorithm's parameters without understanding the root cause. This could lead to unintended consequences, such as wavelength contention, increased latency, or even service outages, violating the implicit expectation of maintaining network stability and service continuity. Another incorrect approach would be to bypass the DWA mechanism entirely for critical services, assuming it will resolve the bottleneck. This is professionally unacceptable as it circumvents the intended functionality of the network, potentially leading to inefficient resource utilization and making future troubleshooting more complex. It also fails to address the underlying issue, leaving the network vulnerable to similar problems in the future. A third incorrect approach might involve relying solely on vendor support without performing initial diagnostics, which demonstrates a lack of due diligence and an abdication of professional responsibility to understand and manage the deployed technology. Professionals should employ a structured problem-solving methodology. This involves clearly defining the problem, gathering relevant data, formulating hypotheses, testing those hypotheses through controlled experiments or analysis, and implementing solutions with robust verification and rollback procedures. This systematic approach ensures that decisions are based on evidence and best practices, minimizing risk and maximizing the likelihood of a successful resolution. Question 14. Assessment of the most appropriate strategy for upgrading a core Nokia optical network segment to a new platform while minimizing service disruption and adhering to strict service level agreements. Option A. Implement a phased migration, establishing temporary redundant paths to ensure seamless traffic rerouting and validate the new system incrementally. Option B. Initiate the upgrade without a predefined and tested rollback procedure in case of unforeseen critical failures. Option C. Execute a direct cutover, where the old system is immediately decommissioned and replaced by the new platform. Option D. Proceed with the upgrade by installing the new equipment and activating it directly without extensive pre-deployment testing in a simulated production environment. Correct answer is A. Implement a phased migration, establishing temporary redundant paths to ensure seamless traffic rerouting and validate the new system incrementally. Explanation. Scenario analysis. This scenario presents a common implementation challenge in optical networking, ensuring service continuity during a planned network upgrade. Professional challenge lies in balancing the need for modernization with the critical requirement of minimizing service disruption for end users. A misstep can lead to significant financial losses for the service provider, reputational damage, and potential regulatory penalties if service-level agreements, SLAs, are breached. The complexity arises from the interconnectedness of network elements and the potential for cascading failures if not managed meticulously. Correct approach analysis. The correct approach involves a phased migration strategy, leveraging the capabilities of the Nokia optical networking equipment to establish temporary, redundant paths. This strategy prioritizes service continuity by ensuring that traffic can be seamlessly rerouted to the new infrastructure or maintained on the old infrastructure until the new system is fully validated. This aligns with best professional practices by demonstrating a commitment to reliability and customer satisfaction. From a regulatory perspective, adhering to established network resilience and service availability guidelines, which are implicitly part of telecommunications regulations, is paramount. This approach minimizes the risk of SLA violations and demonstrates due diligence in network management. Incorrect approach is analysis. A cutover approach, where the old system is entirely replaced by the new one in a single, immediate transition, represents a significant regulatory and ethical failure. This method carries an unacceptably high risk of prolonged service outages, directly violating the implicit requirement for service availability and potentially breaching explicit SLAs. It demonstrates a lack of professional foresight and risk management. Another incorrect approach is to proceed with the upgrade without thorough pre-deployment testing of the new equipment in a lab environment that accurately simulates the production network. This failure to validate the new system's performance and interoperability before live deployment is a direct contravention of professional engineering standards and best practices for network upgrades. It increases the likelihood of unexpected issues arising during the cutover, leading to service degradation or complete failure, and thus potential regulatory noncompliance. Finally, failing to have a detailed rollback plan in place before initiating the upgrade is a critical professional and regulatory oversight. If the new system encounters insurmountable problems, the inability to quickly revert to the stable, existing infrastructure would exacerbate service disruption, leading to prolonged outages and potential regulatory scrutiny. This demonstrates a lack of preparedness and a failure to adequately plan for contingencies. Professional reasoning. Professionals facing such implementation challenges should adopt a structured decision-making process. This begins with a comprehensive risk assessment, identifying potential failure points and their impact on service availability. Next, a detailed planning phase is crucial, outlining the upgrade strategy, including phased implementation, redundancy measures, and a robust rollback plan. Pre-deployment testing in a simulated environment is non-negotiable to validate the new system's functionality and interoperability. Finally, continuous monitoring during and after the upgrade is essential to detect and address any emergent issues promptly, ensuring adherence to service commitments and regulatory requirements. Question 15. Comparative studies suggest that network operators often face challenges when upgrading core optical networking infrastructure to incorporate new technologies. Considering the need to minimize service disruption and ensure network stability, which of the following implementation strategies best aligns with professional best practices and regulatory expectations for network upgrades? Option A. Perform the upgrade during peak business hours. The basic rollback plan in place, but without extensive pre-deployment testing. Option B. Conduct a pilot deployment of the new equipment in a non-critical network segment to validate performance and configuration before a full-scale rollout. Option C. Deploy the new technology across all network elements at once, assuming vendor documentation is sufficient for all operational scenarios. Option D. Implement the upgrade across the entire network simultaneously during the busiest operational periods to expedite the process. The correct answer is B. Conduct a pilot deployment of the new equipment in a non-critical network segment to validate performance and configuration before a full-scale rollout. Explanation. Scenario analysis. This scenario presents a common implementation challenge in optical networking, ensuring service continuity and minimizing disruption during a planned network upgrade. The professional challenge lies in balancing the need for modernization with the imperative to maintain uninterrupted service for critical applications. This requires meticulous planning, risk assessment, and adherence to established operational procedures and regulatory guidelines. The pressure to complete the upgrade quickly can lead to shortcuts, which, if not managed carefully, can result in service degradation or outages, impacting business operations and potentially violating service-level agreements, SLAs, or regulatory compliance requirements related to network availability. Correct approach analysis. The correct approach involves a phased deployment strategy, starting with a pilot deployment in a non-critical segment of the network. This allows for thorough testing and validation of the new equipment and configuration in a controlled environment. It provides an opportunity to identify and resolve any interoperability issues, performance anomalies, or configuration errors before impacting live services. This methodology aligns with best practices for network upgrades, emphasizing risk mitigation and a systematic approach to change management. From a regulatory and ethical standpoint, this approach demonstrates due diligence in ensuring network stability and reliability, which is often a requirement under telecommunications regulations that mandate service availability and quality. It also upholds professional responsibility by prioritizing customer impact and minimizing potential harm. Incorrect approach is analysis. Implementing the upgrade across the entire network simultaneously without prior testing in a live, albeit limited, environment is a high-risk strategy. This approach fails to adequately assess potential issues and could lead to widespread service disruption if unforeseen problems arise. This directly contravenes the principle of responsible network management and could violate regulatory obligations concerning network resilience and service continuity. Performing the upgrade during peak business hours without a robust rollback plan is also professionally unacceptable. This significantly increases the likelihood of impacting critical services and customer operations. It demonstrates a lack of foresight and risk management, potentially leading to severe business consequences for clients and a breach of professional duty to maintain service integrity. Such an action could also lead to regulatory scrutiny if it results in prolonged service outages, especially for essential services. Relying solely on vendor documentation for configuration and troubleshooting without independent validation or internal testing is another failure. While vendor documentation is a valuable resource, it may not account for specific network nuances or environmental factors. This approach outsources critical validation responsibilities and increases the risk of misconfiguration or overlooked issues, potentially leading to service instability and non-compliance with network performance standards. Professional reasoning. Professionals facing such implementation challenges should adopt a structured decision-making process. This begins with a comprehensive risk assessment, identifying potential failure points and their impact. Next, a phased deployment strategy, including pilot testing, should be developed. This should be complemented by a detailed change management plan, including rollback procedures and communication protocols. Adherence to internal operational procedures and relevant regulatory frameworks governing network operations and service availability is paramount. Finally, continuous monitoring and validation throughout and after the deployment are essential to ensure successful implementation and ongoing service quality. Question 16. Governance review demonstrates that a new high-capacity optical transmission technology is ready for deployment to meet increasing data demands. However, the review also highlights potential risks related to interoperability with existing infrastructure and the need for specialized operational training. Considering these findings, what is the most prudent approach to ensure a successful and secure implementation? Option A. Implement the new technology across the entire network immediately to capitalize on its performance benefits without delay. Option B. Deploy the technology only in a simulated lab environment to confirm its basic functionality before proceeding with a live network integration. Option C. Prioritize the speed of deployment by integrating the new technology with minimal changes to existing security configurations. Option D. Conduct a pilot deployment in a limited, non-critical network segment, followed by comprehensive testing and staff training before a full rollout. The correct answer is A. Implement the new technology across the entire network immediately to capitalize on its performance benefits without delay. Explanation. Scenario analysis. This scenario presents a common implementation challenge where a new optical networking technology, designed to enhance network performance and capacity, is being deployed. The challenge lies in ensuring that the implementation adheres to the established operational procedures and security protocols, which are critical for maintaining network stability and preventing unauthorized access. The pressure to deploy quickly to meet business demands can sometimes lead to shortcuts, making a thorough governance review essential. Correct approach analysis. The correct approach involves a phased rollout, starting with a controlled pilot deployment in a non-critical segment of the network. This allows for thorough testing and validation of the new technology's performance, interoperability, and security features in a real-world environment without jeopardizing the entire network. It also provides an opportunity to train operational staff and refine deployment procedures based on initial findings. This methodical approach aligns with best practices for network change management, emphasizing risk mitigation and ensuring compliance with operational guidelines. Incorrect approaches analysis. One incorrect approach is to proceed with a full-scale, immediate deployment across the entire network without prior testing. This poses a significant risk of widespread service disruption, performance degradation, or security vulnerabilities if unforeseen issues arise with the new technology. It bypasses essential validation steps and demonstrates a disregard for established change management protocols, potentially leading to non-compliance with operational standards. Another incorrect approach is to deploy the technology only in a lab environment and assume it will function identically in the live network. A lab testing is crucial. It cannot fully replicate the complexities and interdependencies of a live production network. This approach fails to account for real-world environmental factors, traffic patterns, and potential integration conflicts, increasing the likelihood of unexpected failures upon live deployment and violating the principle of thorough risk assessment. A third incorrect approach is to prioritize speed of deployment over adherence to security best practices, such as neglecting to update access control lists or firewall rules for the new equipment. This creates immediate security gaps, making the network vulnerable to unauthorized access or malicious attacks. It directly contravenes security policies and regulatory requirements for network protection, representing a severe ethical and professional lapse. Professional reasoning. Professionals should adopt a structured decision-making process that prioritizes risk assessment and adherence to established governance frameworks. This involves understanding the potential impact of new technologies, planning for phased implementation with rigorous testing, ensuring comprehensive staff training, and meticulously following security and operational protocols. When faced with pressure to expedite deployment, professionals must advocate for a balanced approach that meets business needs while upholding network integrity and compliance. Question 17. To address the challenge of upgrading a critical optical network segment to a new software version while ensuring minimal service disruption and maintaining data integrity, what is the most professionally sound implementation strategy? Option A. Proceed with a full network-wide software upgrade during a scheduled maintenance window, relying on the vendor's assurance of stability without prior independent testing or rollback planning. Option B. Implement the software upgrade in a phased manner across different network nodes, with extensive pre-deployment testing in a lab environment and a documented rollback procedure for each phase. Option C. Execute the software upgrade on a single, non-critical node first to observe its behavior, and if no immediate issues are apparent, proceed with a full network-wide upgrade without further testing or rollback preparation. Option D. Initiate the software upgrade on all network nodes simultaneously during a period of anticipated low traffic, assuming that any issues will be resolved quickly through real-time troubleshooting. The correct answer is B. Implement the software upgrade in a phased manner across different network nodes, with extensive pre-deployment testing in a lab environment and a documented rollback procedure for each phase. Explanation. The scenario presents a common implementation challenge in optical networking, ensuring service continuity during a planned network upgrade. The professional challenge lies in balancing the need for modernization with the imperative to minimize disruption to critical services. This requires meticulous planning, risk assessment, and adherence to established operational procedures, which are often guided by industry best practices, and, in a professional context, may be influenced by regulatory frameworks concerning service reliability and data integrity. Though the 4A0-205 exam focuses on technical fundamentals rather than specific regulatory compliance, the correct approach, which involves a phased rollout with thorough pre-deployment testing and rollback procedures, represents best professional practice because it systematically mitigates risk. This method prioritizes service stability by isolating potential issues to smaller segments of the network before a full deployment. The emphasis on testing ensures that the new configuration functions as expected, and the rollback plan provides a safety net, allowing for rapid restoration of the previous state if unforeseen problems arise. This aligns with the professional responsibility to deliver reliable network services. An incorrect approach that bypasses pre-deployment testing and rollback planning introduces unacceptable risks. This would be professionally unacceptable as it demonstrates a disregard for potential service outages and data corruption, which can have significant business and operational consequences for customers. Such an approach fails to uphold the professional standard of due diligence and could lead to a breach of service level agreements, SLAs, and a loss of customer trust. Another incorrect approach, such as performing the upgrade during peak operational hours without adequate communication or contingency plans, is also professionally unsound. This directly contradicts the principle of minimizing service impact. It shows a lack of foresight and planning, potentially leading to widespread service degradation or complete failure during a period when network availability is most critical. The professional decision-making process for similar situations should involve a structured risk management framework. This begins with a comprehensive assessment of the potential impact of the upgrade on existing services. Following this, a detailed implementation plan should be developed, incorporating phased deployment, rigorous testing in a lab or staging environment, and a well-defined rollback strategy. Crucially, clear communication channels with all stakeholders, including operations teams and potentially affected customers, must be established. The decision to proceed with any implementation should be based on the confidence gained from testing and the robustness of the contingency plans. Question 18. The evaluation methodology shows that a network engineer is tasked with optimizing the performance of a customer's optical network. During the optimization process, the engineer identifies a configuration change that, while technically improving overall network efficiency and reducing latency for the majority of traffic, will slightly increase the latency for a specific, low-priority data stream used by the customer for non-critical monitoring. This change was not explicitly discussed or agreed upon in the initial service level agreement, SLA, which guarantees a certain maximum latency for all traffic. The engineer is considering implementing this change without informing the customer, believing the overall network improvement outweighs the minor impact on the monitoring stream. What is the most professionally responsible course of action? Option A. Delay the implementation of the change and request a formal amendment to the SLA to explicitly allow for this type of optimization, even if it slightly impacts non-critical traffic. Option B. Implement the change and inform the customer of the optimization, highlighting the overall network benefits while acknowledging the minor impact on the monitoring stream, and seek their confirmation. Option C. Implement the change and only inform the customer if they raise a concern about the monitoring stream's performance, as proactive notification might cause unnecessary worry. Option D. Implement the change immediately, as the overall network efficiency improvement is significant, and the impact on the monitoring stream is minor and unlikely to be noticed by the customer. The correct answer is B. Implement the change and inform the customer of the optimization, highlighting the overall network benefits while acknowledging the minor impact on the monitoring stream, and seek their confirmation. Explanation. The evaluation methodology shows that understanding the practical implications of network design choices, particularly concerning the impact on service-level agreements (SLAs) and potential customer dissatisfaction, is a key competency for Nokia optical networking professionals. This scenario presents an ethical dilemma where a technically sound solution might inadvertently violate the spirit, if not the letter, of a customer's service expectations, leading to potential contractual disputes and reputational damage. The challenge lies in balancing technical optimization with contractual obligations and customer trust. The correct approach involves proactively communicating the potential impact of the proposed design change to the customer, clearly outlining the trade-offs and seeking their explicit agreement. This demonstrates transparency, upholds professional integrity, and ensures that customer expectations are managed effectively. It aligns with ethical principles of honesty and fairness, and implicitly with regulatory frameworks that emphasize clear communication and adherence to contractual terms and service provision. By involving the customer in the decision-making process, the professional ensures that the final solution meets both technical requirements and customer satisfaction, thereby preventing future disputes and maintaining a strong business relationship. An incorrect approach would be to proceed with the design change without informing the customer, assuming that the technical improvement justifies the deviation from the original understanding. This is ethically unsound as it breaches the principle of informed consent and can be seen as a misrepresentation of the service being provided. It also carries significant regulatory risk, as it could be interpreted as a breach of contract, leading to penalties and legal ramifications. Another incorrect approach would be to downplay the potential impact to the customer, hoping they will not notice or complain. This is dishonest and erodes trust, creating a foundation for future conflict and damaging the professional's and Nokia's reputation. It also fails to uphold the professional duty of care to ensure the customer receives the agreed-upon service quality. Professionals should approach such situations by first thoroughly analyzing the technical implications of any proposed change. Subsequently, they must assess these implications against existing contractual obligations and customer expectations. If there is a potential for negative impact or a deviation from agreed service levels, the next step is to engage in open and honest communication with the customer. This communication should clearly articulate the proposed change, its potential benefits, and any associated risks or impacts on service. The goal is to achieve a mutually agreeable outcome through informed discussion, thereby fostering a collaborative and trustworthy relationship. Question 19. The monitoring system demonstrates an unusual pattern of traffic spikes on a critical optical network segment, occurring precisely during a scheduled maintenance window for a major enterprise client. The spikes are not indicative of any known planned traffic increase or system test. What is the most appropriate immediate course of action for the network engineer? Option A. Immediately escalate the issue to senior management without performing any initial investigation. Option B. Immediately initiate a network isolation procedure for the affected segment to prevent potential unauthorized access or disruption. Option C. Continue with the scheduled maintenance, assuming the traffic spikes are unrelated or a temporary anomaly. Option D. Gather additional diagnostic data, correlate the spikes with system logs and client activity, and consult network documentation before taking any action. Correct answer is B. Immediately initiate a network isolation procedure for the affected segment to prevent potential unauthorized access or disruption. Explanation: the monitoring system demonstrates an unusual pattern of traffic spikes on a critical optical network segment, coinciding with a scheduled maintenance window for a major client. This scenario presents a professional challenge because it requires immediate judgment under pressure, balancing the need for network stability with client service commitments and potential security implications. The ambiguity of the traffic spikes, whether they are legitimate, a precursor to an issue, or indicative of unauthorized activity, necessitates a cautious yet decisive response. The correct approach represents best professional practice because it prioritizes a systematic, evidence-based investigation before taking potentially disruptive action. This aligns with the ethical obligation to maintain network integrity and provide reliable service, while also adhering to the principles of due diligence and responsible network management. By first gathering more data and consulting relevant documentation, the network engineer avoids premature conclusions and ensures that any subsequent actions are justified and proportionate. This approach minimizes the risk of unnecessary service interruptions, which could lead to contractual breaches and reputational damage, and upholds the professional standard of thoroughness. An incorrect approach would be to immediately assume the traffic spikes are malicious and initiate a network shutdown or isolation without further investigation. This represents a failure to exercise due diligence. It could lead to an unwarranted service disruption for the client, violating service-level agreements, and potentially causing significant financial losses for the client. Ethically, it demonstrates a lack of professional restraint and an overreaction based on incomplete information. Another incorrect approach would be to ignore the anomaly, assuming it is a transient issue or a false positive, and continue with the scheduled maintenance. This is professionally unacceptable, as it neglects a potential threat to network stability and security. It violates the duty of care to monitor and maintain the network effectively. Ignoring such anomalies can lead to cascading failures, service outages, and security breaches, all of which have severe professional and potentially regulatory consequences. A third incorrect approach would be to immediately escalate the issue to senior management without attempting any initial diagnosis or data gathering. While escalation is sometimes necessary, doing so without any preliminary investigation demonstrates a lack of initiative and problem-solving capability. It can overload management with information that could have been filtered or resolved at a lower level, and it delays the resolution process. Professionally, it suggests an unwillingness to take ownership of a problem within one's purview. The professional decision-making process for similar situations involves a structured approach. 1. Observe and document. Note the anomaly and its context. 2. Gather data, collect relevant logs, performance metrics, and configuration details. 3. Analyze, correlate the anomaly with known events like maintenance and potential causes. 4. Consult, refer to documentation, best practices, and potentially colleagues or supervisors if the analysis is inconclusive. 5. Act, implement a solution or mitigation strategy based on the analysis, prioritizing minimal disruption and maximum effectiveness. 6. Verify, confirm the resolution and document the outcome. Question 20. Stakeholder feedback indicates a vendor representative has offered to provide detailed performance metrics and network architecture insights for a key competitor's deployed solution, suggesting this information would help the network engineer better understand the competitive landscape and justify selecting their product. The engineer is currently involved in evaluating new optical networking solutions. Option A. Share details about the competitor's network that the engineer has access to through their current role, framing it as helpful context for the vendor's understanding of the market. Option B. Accept the vendor's offer of competitive network data, as understanding competitor weaknesses is crucial for making an informed decision and securing the best solution. Option C. Politely decline the vendor's offer, stating that the evaluation will be based on objective technical criteria and publicly available information or vendor-provided specifications, and redirect the conversation to how their product meets the defined requirements. Option D. Acknowledge the vendor's offer but proceed with the evaluation without explicitly addressing the ethical implications, assuming the information will not be used. The correct answer is C. Politely decline the vendor's offer, stating that the evaluation will be based on objective technical criteria and publicly available information or vendor-provided specifications, and redirect the conversation to how their product meets the defined requirements. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent conflict between a vendor's desire to secure future business and the ethical obligation to provide objective, unbiased technical advice. The network engineer is privy to sensitive information about a competitor's network performance, which could be leveraged to unfairly influence a purchasing decision. The challenge lies in navigating the pressure from the vendor, while upholding professional integrity and adhering to procurement guidelines that mandate fair and transparent evaluation processes. Correct approach analysis. The correct approach involves politely but firmly declining the vendor's offer of proprietary competitive information. This upholds professional integrity by refusing to engage in practices that could compromise the fairness and objectivity of the network evaluation. It aligns with ethical principles of impartiality and transparency, ensuring that purchasing decisions are based on merit and technical requirements, not on potentially biased or illegally obtained information. This approach also respects the vendor's legitimate interest in showcasing their product, but redirects the conversation to factual performance data and technical specifications relevant to the evaluation criteria. Incorrect approaches analysis. Accepting the vendor's offer of competitive network data would be a significant ethical and regulatory failure. It introduces bias into the evaluation process, potentially violating procurement policies that require a level playing field for all vendors. This action could be construed as receiving an unfair advantage, undermining the integrity of the procurement process and potentially leading to a suboptimal network solution if the decision is influenced by skewed information. It also breaches confidentiality if the competitive data was obtained improperly. Sharing the information about the competitor's network with the vendor, even if obtained through legitimate means, is also an ethical and potentially regulatory breach. This action violates the principle of confidentiality regarding existing network infrastructure and operational details. It could also be seen as an attempt to manipulate the competitive landscape, which is unprofessional and could have legal ramifications if it constitutes a breach of contract or anti-competitive behavior. Ignoring the vendor's offer and continuing with the evaluation without addressing the ethical concern is insufficient. While not actively engaging in misconduct, it fails to proactively address a situation that could lead to ethical compromises. A professional must actively manage ethical dilemmas, not passively hope they resolve themselves. This passive approach leaves the door open for future pressure or the perception of impropriety. Professional reasoning. Professionals facing such dilemmas should follow a structured decision-making process. First, identify the ethical conflict and relevant professional codes of conduct or organizational policies. Second, gather all relevant facts and understand the potential consequences of each action. Third, consider the principles of fairness, transparency, and integrity. Fourth, consult with supervisors or ethics committees if unsure. Finally, choose the course of action that best upholds professional standards and minimizes harm, even if it means declining a potentially beneficial offer or confronting an uncomfortable situation.